In this lesson, we're going to focus on topic 2, the standard reduction potential table. So let's have a brief look at the construction of the table. The whole table is written as a gain of electron, which is reduction. They are examples of half reactions of reduction for particular species. But keep in mind that these equations are reversible. On the left side of the table is the oxidizing agent, while on the right side of the table is the reducing agent. Species on the left side of the table have an increased tendency to reduce as you move up, which means as you move up on the left side of the table, the oxidizing agent will be stronger. Species on the right side have an increased tendency to oxidize as you move down, which means as you move down on the right side of the table, the reducing agent will be stronger. On the right side of the table, there is also the cell potential, represented by E, and it's measured in volts. The higher the cell potential, the stronger the oxidizing agent. Another thing we need to know about is spontaneous reaction. Here's a quick definition for it. A spontaneous reaction is a reaction which occurs by itself, without outside assistance. So now, let's talk more about cell potential. We use fluorine as an example. Let's look at this example. F2 plus 2 electron and form 2F minus, and it has a cell potential of plus 2.87 volts. So, what does positive 2.87 volt mean in the cell potential? In this case, the cell potential is positive, so the reaction is spontaneous in the forward direction. What if the reaction have a negative cell potential? Like this reaction, sodium 1 plus reacts with 1 electron and form sodium. It has a cell potential of negative 2.67 volts. When the cell potential is negative, the reaction will be non-spontaneous in the forward reaction, but it will be spontaneous in the reverse reaction, because when you reverse the reaction, the cell potential will change from negative to positive. So here are some questions. There is two reactions shown above, and the first question is compare F2 and Cl2. Which is the stronger oxidizing agent? You can pause here and have some time to think about it. Looking at the cell potential for both of these reactions, the cell potential for fluorine is larger than the cell potential of chlorine. So, fluorine is the stronger oxidizing agent. Okay, let's move on to the next question. Compare F2 minus and Cl minus. Which is the stronger reducing agent? For this question, you also need to compare the cell potential value of the reverse reaction of the above equations. So, the cell potential after reversing will just be negative value of the original cell potential. So the cell potential of Cl minus is negative 1.36 volts, and the cell potential for F minus is negative 2.87 volts. We can see that the cell potential for Cl minus is larger than the cell potential of F minus. So, F minus will be the stronger reducing agent. Here is another quick review. Compare those reactions below. Which is the strongest oxidizing agent, and which is the strongest reducing agent? I'll give you a second to think about it. Okay, time is up. The strongest oxidizing agent is Ag+, and the strongest reducing agent is sodium. The answers are pretty straightforward. When looking for the strongest oxidizing agent, you can just look for the one with the highest cell potential value. Same for the strongest reducing agent. You can just look for the one with the smallest cell potential value, because when you reverse the reaction, the smallest cell potential value will be the largest cell potential value. If you have learned all the points that were taught in this lesson, congratulations, and hope you do better in chemistry.